Hello students, today we're going to talk about parallel and perpendicular lines. So this might be a little bit of a meatier section, but I want to make sure that we spend the time to cover this thoroughly. So at the end of this lesson, you should be able to determine if two lines are parallel, perpendicular, or neither. So to go over a couple of the definitions, we want to talk about parallel. Parallel lines, if you don't already know, are lines that never touch. And the way we determine if lines are parallel is if the slopes are the same or if their slopes are equal. So what we'd want to do is look at the two equations in question, look at their slopes. If they're the same, they're parallel. To determine if it's perpendicular, we actually take the product of their slopes, and that should be equal to -1. So let's practice on a couple. So we look at the equation, or the question that says, are these two lines parallel or perpendicular? So it should always be, you should always look at these when you are asked this question in the following manner. One, let's see if their slopes are the same. So remember, y equals mx plus b should be the equation of a line for slope-intercept form, where m is your slope and b is your y-intercept. So what we're going to do is we're going to play match. We're going to take our equation and put it right over the 2, and we're going to look at them. So this was y equals mx plus b. This is y equals 2x, which means the slope here is 2. And the slope for the second one is m equals 2. Now, notice, because they are the same, that means they're automatically parallel. Now, let's take a quick check for perpendicular. If these two, the slopes, we multiply them to 2 times 2, well, that's equal to 4. Now, because it's not equal to -1, it's automatically not perpendicular. So we have another test that we can try, or another problem we can try out right here. It says, find the product of their slopes. If it's -1, then it's perpendicular. So that's what we proved here. Let's try again. So are these are these linear equations parallel or perpendicular? So in order for us to test that, we actually need to find the slope for each one. Now, to help us figure that out, we need to find the slope, or the change in y divided by the change in x, or what you guys always know as rise over run. So I'm actually going to draw lines, or straight lines, creating a right triangle from one point to the other. So from here to down here, and here to here. And the reason why I chose these lines is because I wanted it to make a right angle, and they also gave us 2 points to test out. So to go from this point up here to this one down here, we have to go 1, 2, 3, 4, 5, 6 down. So we would write -6, just to keep tabs on that. And then to go right, we have to go, or to go to the next point, which is here, we have to go 1, 2, 3, 4, 5, 6, 7, 8. 8 to the right. Now because it's to the right, it's positive. So for this slope, or for the slope of that line, we're going to write as m equals -6/8. Let's try it for the second one. We're going to use the points they give us and draw a right triangle. So from this point, from here to here, and here to here. Notice, if you really wanted to, you could also draw the triangle from here to here, which we're going to do in dashed lines, and here to here, just to give you an idea that it doesn't make a difference as long as your triangle is a right triangle. So we have to go up 1, 2, 3, 4. So we have to put in 4. And to the right we go 1, 2, 1, 2, 3. So that's 3. So our rise in this instance is m equals rise is 4 divided by run, which is 3. So notice that the lines are not the same. Because they're not the same, we can say that they're not parallel. So, are the slopes the same? Nope, they are not. Therefore, they're not parallel. For the testing if they're perpendicular, what we're going to want to do is multiply their slopes and see if that's equal to -1. So I'm actually just going to move this so it's easier. So, are the product of their slopes equal to -1? Well, we have our 4/3, which is right here, and we have this one, which is -6/8, which, if we simplify, turns out to be -3/4. So when we take the product of these two things, it is equal to -1. So yes, and these three little dots mean therefore. So yes, therefore the lines are perpendicular. Okay, another way to test it is if we take the negative reciprocal, which is a fancy word for flip it over and make it negative. So 4/3, if we flipped it over, that'd be 3/4. If we made it negative, it'd be -3/4, which is the same exact thing as this, just simplified. Another one is write an equation for the line that is perpendicular to MN that contains the point P. So they give us an equation of a line here, which is MN. So what we're going to need to do is, 1, find the slope of the given line. So it's y equals mx plus b. Therefore, here is your m, which is our slope here, which is 2/3. Second, it says find the parallel or perpendicular slope based on step 1. Now in the problem, they're asking us for perpendicular. Remember, when we change slopes into perpendicular slopes, we flip it over, or we take the reciprocal of 2/3, which is 3/2, and then we make it negative, giving us -3/2. Number 3 says use point slope form and substitute your given point and slope found in step 2. So remember, point slope form is y minus y sub 1 equals m times the quantity x minus x sub 1, where m is your slope and x sub 1 is the given point and y sub 1 is your given point for y and x respectively. So our points, I'm going to make this a little bit bigger so it's easier for you guys to see. We have y minus 6 equal to -3/2 x minus 6. So notice the -3/2 are perpendicular slope. And we got our x and y values from here x and here y are 6 and 6. Step 3 says use the point slope form and substitute your given, which we just did. Step 4 says solve the point slope form so that it's in slope intercept form, or y equals mx plus b. So in order for us to get there, notice that we have y minus 6 plus y minus 6 equals -3/2 x plus 9. So in order for us to do that, we need to add 6 to both sides, leaving us with the following. Y equals -3/2 x plus 15. So that's how we create a line that's perpendicular. To do parallel, we'd go through the same exact steps, but in step 2, we'd use the parallel slope. One more thing to note. As you go through and you're determining if lines are parallel, perpendicular, or neither, again, we check to see if they're parallel, and if they're not parallel, we check to see if they're perpendicular. If it's neither of those, or if it's not parallel or perpendicular, then obviously the answer is neither. So now it's your turn. Go ahead and try to solve these two problems, and remember to please post your answers to Edmodo. That's all for now. I'll see you guys next time.